Well, welcome everybody. It's an honor to speak to you today about a topic near and dear to my heart, and that's principle-centered leadership. I've had the pleasure and pain of being in a leader position for almost 40 years at different multinational companies. I've led dimensional engineering teams, design engineering teams, total vehicle teams, and my last job before retiring and joining DCS, I was the global design for Six Sigma leader at General Motors. The key to success in all those jobs was leveraging the teams that I had and working with others to achieve business results that exceeded expectations and provided business success. I developed a servant leader mentality, leading and mentoring. Today, I want to provide you with some insight to enable you to achieve your goals and objectives as well and exceed expectations. So how can we do this? I've mentioned it before of being a leader-centric servant leader. What many people want to do is focus on tools and methods. And I found that principle-centered leadership will take you farther and faster than any tool or method could possibly do. And I'm going to today map from Stephen Covey's 7 Habits of Highly Successful People to everyday habits that engineers can use to improve their business results on the day-to-day shop floor. So we'll talk a little bit about the tools and methods. We'll talk about principle-centered leadership, and then I'm going to get into the 7 habits of highly effective engineers. You know, tools and methods are great. I love tools and methods. And what many people ask me are what are the most important tools an engineer should learn and use. And they're usually looking for a small set of 1 or 2 tools. And I always say, you know, you're asking the wrong question. Don't focus on tools and methods. Tools and methods will only take you so far. Now, they're great. Don't get me wrong. In all of my roles, I've used a myriad of tools and methods. And in most of roles, I develop new materials, new tools and new methods, or stretch the old ones. I love learning, creating, applying tools and methods. Some trusty old ones and some really dynamic new ones. However, focusing on tools and methods isn't going to get you there. Tools and methods are great, but they only take you so far, and they frequently can be misused. People grab the wrong tool for the wrong application, like I've shown here with the hammer and a screw. And then nothing good ever happens with that. So I always say that's really the wrong questions. I like tools and methods, but let's focus on the right thing. And the right thing is focusing on principle-centered leadership. Principle-centered leadership is a framework to hang all your tools and methods in, and it will get you a lot farther and a lot faster than any tool and method would. Principle-centered leadership usually is using these time-worn, time-proven, fundamental truths that drive what you do and how you will act and how you will impact others. And that's the key. So what we want is a set of principles that drive our behaviors, and we make sure we're doing the right thing at the right time, at the right place to reach the right goals. With that, we can make huge strides and impacts on the business. Now, Isaac Newton once said, if I had been able to see further, it was only because I stood on the shoulders of giants. Likewise, I don't want to compare myself to Isaac Newton, but I too am able to stand on the shoulders of giants. I've had a lot of great leaders in my time, people who taught me so many things and helped me become a better leader and helped my career path grow. And one of those leaders sent me to a class at a key moment in my life. You know, I was transitioning to an expanded leadership role, And at the same time, I was learning to manage the complexity of life with a toddler, and my son Andrew's little sister was on the way, and we had just moved to a new city, and life was a bit of a struggle. And my boss at the time recognized that, and he sent me to a class that changed my life for the better. And in fact, that class changed my life not just for the better, but forever. And that class was the 7 Habits of the Highly Effective Person. My talk today is about the highly effective engineer, but it's based on the 7 habits of the highly effective people. It was written by Stephen Covey in 1989. It had 7 habits that people have learned, and I hope many of you have at least heard of this. And then in 2004, he wrote another book called The 8th Habit, which was subtitled Find Your Voice, Inspire Others to Find Theirs. I've discovered that many of the top leaders I work with also shared that same class, and that same class shaped the trajectory of their careers as well. So I thought this would be a good thing to talk about today. I was asked to talk about lessons learned over a career, and I thought, what is the most important lessons? And I think this is it. Now, Stephen Covey's huge bestseller is still on the bestseller list. It's taught many places. I know my grandchildren are learning this in their elementary school. The 7 habits of being proactive. Begin with the end in mind. Put first things first. Think win-win or no deal. Seek first to understand and then to be understood. Synergize and sharpen the saw. These are just time-worn, awesome principles to guide your work on a day-to-day basis. I strongly encourage you to buy the book or find the book and reread the book if you can. It's just a great lesson. Now, I don't think I want to just go over the book by itself. I'm going to be very specific. And I thought I would provide a subset of ways to apply 7 habits to an engineer or engineering leader role. And these are things that helped me and many of my friends who have senior leadership positions in major corporations all agree will help you get business results quickly and efficiently. So these are the 7 habits of the highly effective engineer. I've taken each of Covey's and translated it slightly to introduce a key topic that can drive great behavior. So be proactive is don't be afraid to fail. But if you're going to fail, fail fast and fail cheap. Begin with the end in mind. What does that mean? Where do we begin? Well, let's begin by using the scientific method. Putting first things first. Hey, Pareto was right. Let's use the 80-20 rule to drive what we work on, when we work on, and where we work on. Think win-win or no deal. That is, be driven by data, but not, or be data-driven rather, but not driven by data. It's just a subtle change, and we'll talk about that. Seek first to understand, then be understood. Hey, talk less and listen more. This is the hardest one for me because I can be a bit of a talker, but I'll talk a little bit about this as we go on. Synergize, relationships matter. Sharpen the saw, master the physics of your product or process. Sharpen the saw was really, just keep hone your skills, keep working and making things better, do some maintenance. I'm going to tell you, as an engineer, the most important thing you can master and maintain is the understanding of physics of the product or process you're working on. And then inspire others, the 8th habit, and that is to be a mentor. So on the following slides in the following few minutes, I'll share with you. I'd like to go into each one a little more detail. This is one of my favorite quotes. It's from Michael Jordan, the all-time great basketball player. Unfortunately, I'm from Detroit, and he played for the Bulls, and we had some great battles between the Pistons and Bulls. But you had to respect this guy. He was just incredible. He said, I've missed more than 9,000 shots in my career. I've lost almost 300 games. 26 times I've been trusted to take the game-winning shot, and I missed. I've failed over and over and over again in my life, and that is why I succeed. I love this quote because it really talks about the topic at hand of being proactive. And being proactive is, let's have some motion, let's do something. But you know what stops a lot of people from doing anything? They're afraid to fail. They say, oh man, I've never been afraid to fail. I like the Michael Jordan thing. I'm willing to take risks, but if I'm going to fail, I'm going to fail fast, and as Dave Johnson says, fail cheap. What I want to do is create momentum and show progress. I want action, TNT, today, not tomorrow. Action TNT is a little acronym I learned from another great leader whose shoulders I stand on. Just remember that progress isn't always a straight line. How many times did Edison fail at making a light bulb before he succeeded? So what you want to do is just create momentum and create progress. And so one of the tools I use to show progress is a solution tree. This is something I borrowed from the Red X and Shannon. And it includes possible solutions to a problem. And then as we go and test them, we can draw a line through the ones that prove to not be true. And as you can see here, I have a solution tree that includes a lot of non-solutions because a lot of things were crossed out because we ran a test and said it can't be that. And then with this, we're searching for what the solution is. But as we go, we are making progress because we are showing what it is not. Now, I had a boss once who didn't like that. He goes, oh, I don't see you getting solutions. I see a lot of knots, and I don't understand why the chief engineer loves it. My point was, hey, I showed more progress in a week of what it's not than they did in 2 months of talking about it in meetings. And the thing was, I wasn't afraid to fail. I just went out and got data and was able to say, oh, can't be material, can't be handling, can't be this, it has to be something else. And while we're doing excluding some, we are honing in on an answer. So just remember that don't be afraid to take risk. A failure is progress, and a failure is a learning moment. And frequently, by gathering data, you would learn some new things that would help guide where you're going. So make sure if you do fail, do it fast, but don't be slow. And I would always know if as I tested any one of these, I knew where I was going to go based on what the answer was. If yes, then this. If no, then that. And so I just kept moving and moving and moving quickly and efficiently towards a final solution. And it was interesting because I told you about my boss. He didn't get it. He was just like, I don't get it. What? And as I told you, I was leader of the Design for Six Sigma initiative at General Motors globally. And if you wanted to become a master black belt, you had to go through me. And this young gentleman who was my director, new to the position, executive leadership, and he just said, I don't get it. What makes you the master? I see a lot of no solutions. And I said, look, dude, you're just looking at it wrong. I'm a master because I've tried and failed more times than you've even tried. Failure was and is always just one step on the road to success. That's why I'm the master. I understand I don't make mistakes twice, but I'm willing to make them, and I'm willing to move quickly. When we got done with that program, the chief engineer was ecstatic because we quickly, where nobody was afraid to gather data. It was okay if you were wrong as long as you moved quickly, and we started solving problems at a rate that they had never seen before. All right, I want to move on to the second habit, and that in Stephen Covey's, he talks about begin with the end in mind. What does that mean? As an engineer, I like to think of begin with the end in mind is to use the scientific method. If I had to pick the greatest tool in my tool bag, it would be the scientific method. And you're all familiar with the scientific method, I'm sure. You observe from your observations, you form some hypotheses, these what if, it could be this, it could be that. I don't act on those hypotheses until I test them. So I find some clever way that I can quickly and simply test whether the hypothesis is true or false. I gather data, and based on the data, I can make some conclusions. And then I can repeat as needed. If the hypothesis is confirmed, what does that mean? Where do we go next? We can have some new hypothesis, some new tests, some new conclusions. If it's proven false, what do we do next? Remember what I said in the last habit? These are all interrelated. If the hypothesis is proven false, what am I going to do next? Fail fast. So this is one of the things that allows you to go fast, is using the scientific method. Now, is this some fancy thing? Oh, no. When did you learn this? I think most of us learned this maybe in junior high, or in high school, or in early college. This is not advanced math or anything like this. It's pretty basic. Unfortunately, as I observe a lot of people, they seem to have forgotten about it and they don't use it. And then they're often wondering, how come they're not moving forward as fast as they want? And it's like, because you're forgetting the basics. And the scientific method is one of the basics that will serve me well over and over again throughout my career in many, many jobs. Working without hypothesis is slow and wasteful. And, you get all these people talking or acting without hypothesis, and they have a bit of a struggle. One of my many jobs I had was I was pretty good at problem solving, and I launched many a vehicle. And I would be either on the launch team or sent after launch started because they were struggling. And I would try and help them get through launches. And almost every launch, I would meet these people who would sit out in the trailer. If anybody's been to a vehicle launch, you got these engineers who are sent out of town to wherever the plant is. They're given a desk and a trailer, temporary housing, or maybe in some loft area. And I would see these people, they would just be at their computer all day, just looking at numbers, looking at numbers. Every time, it would happen in every launch, and I'd finally come over and introduce myself and say, what are you doing? Well, I'm looking. Looking at what? I'm looking, I have this problem, and I'm looking for an anomaly in the data. Well, what's an anomaly? What's your hypothesis about what an anomaly is? Almost always their hypothesis was, I'm looking for something out of spec, out of specification, because if everything's in spec, the vehicle will be in spec. Now, is that a fact? That sounds plausible, but is it? Let's test. So frequently I'd say, go find the out of spec that you think is going to cause it, and then come and see me, and we'll take some data. So their hypothesis is out of spec, it causes the problem. Now look at the little graph on the lower left. This is typically what I would frequently find. The x-axis is the internal variable measurement that we make on an in-process part that is out of spec. The y-axis is the measurement we're trying to control or reduce the variation or shift the mean. And I would grab their data and then measure on the vehicles that I had the data. I could measure the output, and then I would plot it and look at that. Does there look to be a relationship between X and Y? I don't think so. I would say that this hypothesis that the out of spec caused the problem was busted. It was proven to be false. This really caused a lot of consternation with some people. They go, oh, I don't get it. I go, that's interesting. Well, we find out what is causal. So we would look for other variables and then look for the relationship between X and Y as shown on the right, where in this graph, about 85% of the variation in Y can be explained by the variation in X. Now, so what I'm saying is that X or Y is caused by X. So if we have too much variation in Y, we have to do something with X. Now, their problem they had was it's in spec. It can't be part of the problem. That is a hypothesis that has been busted so many times. I don't know why people hold on to it. In spec is good, out of spec is bad. I think we can say that is a hypothesis. It needs to be tested, as I said up on the top of my last line of the screen. Sounds plausible, but let's test. That'll help you go a long way. So the scientific method of just recognizing what is a hypothesis, what is not, and almost always, if we have a hypothesis, we should test it. So let's be very specific what our hypothesis is and get data. All I want to know is the hypothesis, true or false. So now I can get the right data at the right time to drive the right decision. And so it helps me go fast and easy, and you can move really quickly through things. It's really pretty straightforward. Ready, aim, fire. Not ready, fire, ready, aim. You got the aiming is test your hypothesis. And for those of you who don't remember what the scientific method is, I recommend you go watch Mythbusters. What a great show. It's where they challenge urban legends, myths, and folklore. Go be a Mythbuster. And it's a great show. Teaches young people and people, non-scientists, non-engineers, what the scientific method is. Go watch it. And that's what you should do. Go be a Mythbuster. Great show. Although I will say, whether they confirm the myth or bust the myth, at the end there's an explosion, so that's a lot of fun. Go watch that, but don't cause any explosions. It's not advocating that. Enough about that. I want to keep moving and keep some motion and use your time well. So I want to talk about the third habit, and that in Covey's terms, it was put first things first. What does that have to do with us engineers? I would say Pareto was right. Pareto was right. Who is Pareto? Pareto. He was an econometrician who created the 80-20 rule, which I hope many of you have heard of. The 80-20 rule is where we separate the vital few from the trivial many. 80% of the effects come from 20% of the causes. Or, it's 80-20. It's a general rule that follows many things. If you go to a real estate office, 80% of the sales are done by 20% of the realtors. If you get into retail business, 80% of the revenue comes from 20% of the things on the shelves. So you have the vital few and the trivial many. What we want to do is make sure we're always focused on the vital few. So a corollary to focus on the vital few is ignore the trivial many unless they become vital. And they would become vital if, for example, if we lower the water to expose the rocks by getting rid of the high impact vital few and taking care of them, then the other ones will rise in importance. How do you know which ones are vital few? Hey, again, there's going to be a common theme across this presentation, I think, is test, don't guess. So in the hypothesis, we want to test that. Here I want to test what is important and what is not important. So I need to get some data and create some Pareto charts, not some untested fishbone diagrams. So for example, I like fishbone diagrams. Great tool, great method. However, it is all those little branches are hypotheses until we test them in the actual world. So I do create a fishbone diagram. I then test the fishbone diagram. I then find out which ones are the most important, which ones have the biggest impact, and I work on those first. I ignore all the small stuff. So it's really about choosing how to spend my time and how to spend your time wisely. If you want to improve your performance, spend your time on the most important things. Spend your time on the most timely things. This could be in terms of effect, or it could be in terms of importance from a time perspective. Just remember, always have some action today, not tomorrow, on the most important thing. Let's be impactful, work on the right things. Let's not be busy. I did a lot of career mentoring, and there were a lot of people who didn't understand why they didn't move forward because they spent a lot of time at work. And other people spent less time at work but got moved up ahead. And it was the difference between working on being impactful and being busy. You don't get promoted for being busy. One of my favorites is think win-win or no deal. This is something I guess my children and I talk about a lot. They're in business. We try and find when we deal with others, try and be a way where everybody can win. But I want to spin this also a little bit differently for those who are engineers, particularly dimensional engineers, and that is when we want to think win-win, we want to be data-driven, but we don't want to be driven by data. Just remember, without data, all you have are opinions, and most of them stink. Too often, when people don't have data, they want to talk about it. Who's been to a meeting where people talked and talked and talked, but nobody had any data? This is a form of waste. You get into lean engineering and look at the organization and how we behave. Talking without data is waste. So let's, instead of talk about it, let's go get the data. And there'll be two cases. The data exists, in which case we have to find it, or the data doesn't exist, so therefore we need to develop it. And that's pretty simple, right? And then DCS can help on that. That's one great thing about working for DCS. We have so many tools and methods that can help you with this. To create and analyze new data, we can use the 3 DCS variation analyst or DVM or PVM tools that will help us to create models, to create data, check hypotheses, etc. QDM, the Quality Data Management System, is a great method for pulling the data that has been generated at the plant through actual build data. Both tools are great. Highly recommend using them. It's great that they kind of have this synergy. But when you get the data, let's make sure that we are using it wisely. And we live in a data-rich world because we can either get a lot of plant data through QDM or generate tons of data through the variation analysis tool. But got to be careful on how we do it. Avoid mining data without a goal. How do you know if you have the right data? And then you got to make sure you're following the data. So one of the things, again, the synergy of the 7 habits is how they all interplay with each other. And that is hypothesis, confirmed or busted. Hey, that was a previous one, but it's related to this. How do you know if you have the right data? It's just related to, do I have my hypothesis? Is my hypothesis right or wrong? And then given what I learned from this set of data, let's form some new hypotheses. One of the things I want to talk about too is plotting the data. Is this a tool or a method? I guess it is, but beware of statistics in a vacuum. I love statistics, don't get me wrong. I went and got a degree in statistics because I'm a geek. Love statistics, but I'm really hesitant to use statistics without in a vacuum, and certainly very hesitant to look at statistics without looking at the plot of the data. It's as important or more than the statistics themselves. I'm going to tell a couple of stories about this, about people who are driven by data, and I like to be data driven, and I'm going to bookend it with I spent about 25 years at General Motors, and I'm going to talk about my first week and my last week at GM before I retired, and it's a similar story. The first week, they were launching a vehicle. I know that one of my teammates had been struggling with a problem, and my boss finally asked me to talk to him and help him with it. And he's showing me all this data. We have, as you can see with the table here, we got some specifications, and we have a lot of variation, significantly more variation than they wanted. We have a huge proportion of percent off spec. Given this, they actually kicked off a new tool to build a new die, and they were going to kick off a major revision to the weld tool to get this variation down. Now, my issue was wait a second, can you plot this data? He goes, well, we're way past that. And I go, I don't care. Can you plot the data? And so they did, and it was really interesting. If you look, everybody just stopped and went, oh, because they had this mental model of a univariate, just normal distribution with a plus or minus 3. That's what their mental model was, given the statistics on the left. Look at the data on the right. You can see we have two populations. One population is pretty much centered around the mean and looks to be pretty in spec, and then we have another population that is shifted to the right. Oh, we didn't see that coming. Well, it turned out what happened was the system had not had Poka-yoke done or error proofing done, and during assembly, the operator would get it in install the part into the wrong state. So the one on the left, the hump on the left, is when it was properly installed. The one on the right was when it was installed incorrectly. My issue with the was no blame for the operator, because it was really a blind load, getting the right position. There was no tactile feedback. There was no way for the operator to do this. So we made a small change to the part. It cost about 3 cents, but when I put in the change so that it was error proofed, all of a sudden the hump on the right disappeared, and now we're in spec, and it costs about 3 cents. Oh, by the way, cancel weldment, cancel the welding tool, cancel the stamping tool. You guys were staring at numbers, not plotting data. So plotting data is a key one. Yes, that was my first week. Let's talk about my last week. It's similar but different. I was working on the General Motors full-size trucks. Biggest program in General Motors. It's where they make their money. My job right before I retired was to lead the problem-solving team for the full-size trucks. They called me when they had a problem, and the description of the problem was all about numbers. So, we have it's a true position of a hole. It can be no more than a true position of 2, so plus or minus 1 in any direction from where it should be. And they were looking at that percent out of spec was 97%. It's a disaster. Estimated high is 3.38. Oh my gosh, what a mess. What are we going to do with this? And again, I asked them, let's just plot it. We have 2 positions. It's the X and Z component, and just plot it. And if you look, the circle in red is where it should be, and you got very few parts in spec. But if I look at this, it's kind of interesting. In the Z direction, it's actually pretty much in spec. It's just off-center. The amount of variation is in spec, but it's off-center. And the variation in the X direction is much larger, and there we do have a problem. And then, but what else does it look like? It looks to me like the part rotated down and rearward. That's interesting. Why don't we just plot data? We got into the habit with Excel and QDM and all these tools where people are so used to looking at numbers. I'm saying get away from numbers and start looking at plots. And almost always it'll give you clues. Once they realized that the part was rotated and had more variation in one direction than the other, we were able to quickly find a solution that got into spec. So So I'm going to move on, trying to keep within a time frame here, because I could go on forever and ever. I'm very passionate about this subject. So I'd encourage you to dig deeper. One of the great ones that Covey wrote about was seek first to understand, then be understood. And so I really don't want to rewrite that one too much at all. I just call it talk less, listen more. I told you I was head of Six Sigma. I used to train masters around the globe. I would teach master belt, black belt classes. Spent quite a bit of time on the road. And then I would mentor people through their master black belt. One of the things we would do is we would set up sessions with the engineers at the different engineering centers around the globe. And most of the people I worked with would say the same thing to myself and my friend Frank, who was my peer. They would go, "You don't talk much." I'd look at them because I like to talk. I'm an extrovert. I talk a lot. Then they said, no. In meeting with engineers, you don't talk much. I said, oh, yeah. Yeah, you're right. I listen, and then I would look at them and say, you talk too much. Now what it is your job is, as a leader, is not necessarily to solve other people's problems. And this is what I would tell people. It's not to solve their problems, to help them solve their problems. And therefore, I'm solving problems with people, not for people. And then later I would ask, when experts would come in, what was their complaint about the experts? And then almost always it was too much talking. And if you've worked for a multinational company, you've had experts usually, from some consulting firm that comes in and they talk to you, tell you how great you are, listen to a few of your things, repackage what you told them and sell it to your leaders, right? So I just go, oh, come on. So what you want to do is make sure don't talk too much, because when you're talking, you aren't listening. What you want to do is you bring some skills and knowledge to the program. The young lady across the table, she brings some skills and knowledge. This older man across the table from me, he brings skills and knowledge. We're all bringing different things to the table. What we want to do is pull it all together, leverage the different parts, and come up with a great solution. So your job is to ask a lot of questions. Don't be afraid to look stupid. That's what one people said, don't you feel stupid? I go, no, I don't feel stupid. I would rather look stupid than open my mouth and confirm it. And what I mean by that is I've met the experts. They say things. Management loves them because they sound intelligent, but when you think about it, you go, that's a really stupid thing. It can't be. So I would rather look stupid than confirm it. So practice your active listening skills. Pay attention. Don't judge. Reflect before you speak. Just, quell that urge to develop a response while they're still talking. Just let it go. Reflect. Have some uncomfortable silence while you think about how you want to reply. Rephrase or echo. That's a great technique, echoing what they said to make sure that you understand what they're telling you, and then ask clarifying questions. That'll take you a long, long way. People will see that you are interested, people see that you care, people will want to work with you, and that will help you generate success in the business world. And that will help you develop the sixth habit, which is synergize, or as I wrote it, relationships matter. Because we live in a team-oriented business world, don't we? We're all codependent. We need each other to achieve success. I've never had a job where I could go it alone. Been in business a long time. I'm always dependent on others. So what I want to do is nurture relationships up, down, and across the organization. I just want to have make sure that people, when they interact with me, they feel good. It's a positive experience, and they're looking forward to working with me again. I remember I had that young boss I was telling you about. He would say, Paul, how is it that whenever we get these people from anywhere across the organization who just seem to drop everything and hop on whatever you've asked them to do? How do you do that? Because I can't do that. And he was looking for an organizational answer. I'm a director. They should do that. Mine was, oh, I worked with you in the past. I scratched your back. You scratched my back. We scratch each other's back. So when I asked, they did it out of a sense of togetherness, not organizations, because we had a relationship where we worked together. And we knew, and they knew they would get credit for the work they did from me to their boss, to their boss's boss, and they would be recognized. Now, I never asked them to, do anything to drop their job. I said if I need help, they would help. So you want to make sure you develop some relationships, and especially on the shop floor where the real action is. I took great pride in working in some of the toughest union shops and developing a relationship with the guys on the shop floor because they had trust. Mine was here's what we're going to do. We're going to collect this data. We'll let the chips fall where it may. And they trusted me on that, and that really helped me go farther, faster. And that's because mutual trust and respect leads to synergy. The 1 + 1 = 3 thing. And that's how you can exceed expectations, developing a real framework for teamwork, and that's going to be work on relationships. I had a boss once who taught me one of the relationships tools, and it was, he called it the donut theory. And I was working in a shipyard. I couldn't get anything shipped, even though I filled out all the paperwork. And finally, he just said, Paul, just show up every day with a box of donuts and get to know these people and in the shipping department, get to know who their kids are, which ones are playing t-ball, baseball, volleyball, whatever. Get to know them, talk to them. Wow, it's really interesting. After I developed a relationship with them at my boss's suggestion, all of a sudden, I never had any problem getting anything shipped. And I was a little mad. I was young. And he said, Paul, it's just human nature. If they're stuck between shipping two things, they're both, and one of them is going to be late, who are they going to ship? The person they know, not the nameless person. You did nothing wrong. You just didn't recognize the importance of teamwork. So again, building on the shoulder of giants, I'm so lucky I've had so many great mentors that taught me things like that. All right, we're getting near the end. I just want to talk about sharpen saw. That's the master the physics of your product or process. Just remember, they're called laws of physics, not suggestions of physics. They're laws of physics. Parts and processes always, 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 always follow the laws of physics. I've discovered, because I frequently pulled into many situations that where they couldn't solve a problem. The reason they couldn't solve it many times was because they had the wrong physics. They were focused on what they wanted to happen. I focused on the physics, which is what must happen. What you want to happen isn't very important. What must happen by physics is important, because that'll give you the clues. So focus on the physics. What I frequently found was they would have a problem, so they're looking at what's wrong. What's wrong with the part? What's wrong with the process? What's wrong with the operator? What's their hypothesis? The physics of the design is correct. Is that always true? And unfortunately, too often I would find that the physics there was a slight error in the physics, and therefore the part wasn't doing anything wrong, the operator wasn't doing anything wrong, the design was wrong. Okay, so how do you do that? You have to hone your skills regularly. That's where Stephen Covey says, sharpen your saw, means just working. There's a reason they taught physics in high school and whatnot. Now, some people don't understand it. I'll tell just a quick story. Again, I'm a bit of a storyteller about my first day at General Motors. And I was moving in, and I had a box of stuff, and there are these things, and you might recognize them that kind of look like this. And I'm putting them up into a case above my desk, and this gentleman came up to me, and I won't use his real name, I'll just say Tony. And Tony came up to me and said, "Hey, what are those?" And I said, well, there are books. And then he said, "What kind of books are they?" And I'm kind of mystified because you may not be able to see it here, but it's, these are some of the classics. Introduction to Mechanics of Solids, Physics, Electrical Circuits. They're all labeled. They're clearly bright covers. I said, they're engineering books. I said, "Why do you have those?" I said, "Oh, that's interesting. Now, Tony, I met you on my walkthrough. I was hired as a leader." I said, "You're on my team, right?" And he goes, "Yes." I go, "I'm going to be watching you really closely. I have these books because we're going to engineer our parts and processes. We're not going to guess." And he goes, "No, no, no, you don't understand. You take what you got, and we do what we did last time, and we modify to fit." I said, "No, no, no. We're going to engineer." Let me tell you, Tony didn't last. He just couldn't make the adaptation to being an engineer and being physics. My goal wasn't to be as good as last time. My goal was to be better. To be better, we had to change. To change, we had to master the physics. All right. As I said, there's a law, not a suggestion. If you have the wrong physics, you have the wrong answers. If you can get to the right physics, you can get to the right answer quickly, so focus on it. But what level of physics? Hey, I love, I mentioned I'm a geek. I love developing tools and methods. School, I've gone to more school than anybody you ever know. I used to say college was the best 10 years of my life, but I'm closer to 15 now. But I do want to say I went there because I liked it and I enjoyed it, and I did apply most everything I've learned, but 50% of the time, everything you need to know is taught in the first year of physics. So that I learned it in high school, maybe you learned it in college. That's really interesting. 50% of the time, that's all you need. Yet, people aren't going to the physics, so therefore they are struggling. But we're not talking advanced physics. 90% of the time, years 1 and 2 of engineering school, so if you have an associate's degree, you probably have enough to do 90% of the work that causes problems where people have the wrong physics. They just forgot to check the physics. They assumed they knew. They say, "Sharpen your saw, sharpen your pencil, show me with some calculations, equations, simulation, etc." Then last but not least, the 8th habit. I was pretty excited when this book came out. A couple of my teammates that worked for me gave me this book for Christmas. I was very happy not both to get the book, and then they also told me that I seem to live this habit, and that's why they thought of getting it for me. And that is to be a leader, inspire others, be a mentor. And that's how I like to live my life, is to give freely and generously of my knowledge, experiences, and skills, and share them. My goal isn't to keep them close and keep everybody else out. It's get it out there. Elevate your team. Elevate the people you work with to help them develop into better and better employees. And I believe you'll be paid back 100-fold. As I mentioned before, I could call people, they would help me right away because they knew that it was a two-way street. I help them, they help me, I help them, they help me, back and forth. So I believe that. And so let's be a leader. Leader is a person with followers. Let's not be a manager who is directing people, but get in there, get dirty, have some fun with it, develop relationships where people will follow you and at least go along with you. All right. So that's, in a nutshell, principled set of leadership with a Paul Vickers spin on it. Again, I was asked to just put together something about what did you learn in 40 years. I thought this is the best. This is probably the most worthwhile thing I can share with you. I hope that I used your time wisely. I want to thank you for using your time and spending it with me. I hope I demonstrated the value of the 8 habits. I hope I inspired you to maybe go dig a little bit deeper and buy Stephen Covey's books and read them. He's not going to get rich. He passed away in a bike accident several years ago. It was a tragedy. But his timeless wisdom moves on. And I highly recommend it. Many of my leaders I've worked with at many companies recommend it. And then the last I would close with is go do something great for your organization. Apply your principle-centered leadership. And I think if we can all pull this way, we will go farther faster. So thank you for your time. And Paul Vickers, over and out.